May, June 2024, paper 2, variant 2. Question 1. Student wishes to measure accurately the volume of approximately 40 centimeters cubed of water. She has two measuring cylinders, a large one that can hold 100 centimeters cubed and a smaller one that can hold 50 centimeters cubed. The water forms a meniscus where it touches the glass. Which cylinder and which level does the student use to ensure an accurate result? Should she choose the larger one? Definitely not. She needs the smaller one, and we take the reading from the bottom of the meniscus. The motion of an object is represented, which quantity is equal to the area under the graph. The area is the distance traveled. An astronaut of mass 80 kilograms is standing on a planet with a gravitation field strength of 3.8. What is the weight? Weight equals mg, so 80 times 3.8, which would give you roughly 300 newtons. A sealed container of volume 2000 centimeters cubed contains air at high pressure. The container is placed on a top pan balance. The balance reads 200 grams. All of the air is removed by a vacuum pump and the reading changes to 196 grams. What is the density? Density equals mass over volume. The mass of the air would be 200 minus 196 divided by the volume, which is 2000, giving you a density of 0.002. Each diagram shows three forces on a beam. In which situation is it possible for all three forces to be in equilibrium? Okay, all of the three forces need to be in equilibrium. Well, I can cancel out B and C. Why can I cancel out B and C? Because of the length of the forces. If you take a look at the magnitude of the forces, I'm just talking about the magnitude of the forces. So, for example, this would be a 10 Newton force, and this would be a 10 Newton force. This would also be a 10 Newton force. So it's kind of not balanced in B nor in C, because you've got 20 newtons and 10 newtons, so they are not balanced, neither in B or in C. A and D seem to be a bit balanced if we talk about the upward forces compared to the downward forces, right? You'd have, for example, this is a 10 Newton force, and you'd have these are two 5 Newton forces. The same goes for D, a 10 Newton force, and two 5 Newton forces. So they might seem to be balanced when talking about the forces. But if we talk about the moments, A does not seem to be balanced. Why doesn't A seem to be balanced at all? Why? Because if you take, for example, the pivot to be, let's say, at this point. For example, just taking an example. If the pivot is at this point, then the clockwise moments would actually be greater than the anti-clockwise moment. The 10 Newton force would cause an anti-clockwise moment, while the 5 Newton forces cause clockwise moments, which would be greater because of the distance, which would be greater. So actually A is wrong, and the only correct answer is D. The only correct answer would be D. Definitely, they are not 10 newtons and 5 newtons, okay? I know that if we take the pivot to be at this point, for example, or at any other point, you'd say 10 newtons multiplied by whatever distance wouldn't be equal. I know, this is fact. But again, the numbers that I put, the 10 newtons and the 5 newtons, the magnitudes of these forces aren't exact. They could differ. Could be greater, could be smaller, and therefore, if you multiply by the distances, it would be in equilibrium. In question 6, a gymnast jumps down from a high piece of apparatus. She gradually bends her knees. Why does she bend her knees? Which effect does this have? Will it have a smaller change in momentum? No, it doesn't have a smaller change in momentum. Why? Because she eventually stops. When she jumps and falls on the ground, she eventually stops. So it does not have a smaller change in the momentum. She will lose less kinetic energy. Again, she will lose the same amount of kinetic energy because she falls. She stops eventually as she hits the ground. She will exert a smaller impulse the same as A. It's the wrong answer. She will experience a smaller force. Yes, she will experience a smaller force. Why? Because as she bends her knees, what happens to the time taken for her to stop? What happens to the time taken for her to stop? The time increases. And we know as the time increases, the force decreases due to the impulse. It's the same impulse, it's the same change in momentum, but as you increase the time, you decrease the force. Table gives four energy resources and states whether the main source of energy for the resource is the sun, which row is correct. Geothermal, the main source is the sun. No. Oil, it is the sun, so this is wrong. It's actually wrong. Water behind the dam, the main source is the sun. Yes, due to the water cycle, the evaporation, whatnot. Wind, it does depend on the sun. The equation delta P equals rho delta H. What is the meaning of rho? It is the density of the liquid. What are the correct terms for each change of state? So, from liquid to solid, solidification. It is solid. Liquid to gas, condensation. No. Liquid to solid, solidification. Liquid to gas, evaporation. Yes. Extremely small pollen grains in water are viewed through a microscope. The grains are seen to move continually and randomly. What is the reason? Brownian motion. The grains are moved randomly moving or by randomly moving water molecules. Yes, by randomly moving water molecules. This is the correct answer. Which graph shows how the volume of a fixed mass at a constant temperature varies with the pressure. So the volume and the pressure, it is an inversely proportional relationship. Inversely proportional. So it is D. It does not touch either axis. Which effect is caused by thermal expansion? A metal surface heating up. Uh, is this no? Ice cream melting. Is this caused? It melts. It doesn't have to do with the thermal expansion. Railway buckling. Yes, the buckling of the railway tracks. Temperature of water at the bottom of the waterfall is greater. The energy in the gravitational potential source, okay, is transferred to the thermal store at the bottom. He gave you a hint of how to solve this question. He actually gave you a hint because the gravitational potential energy is transferred to this to the water. Okay, it's transferred as heat energy. The specific heat capacity of water is 4,200. Can I find the temperature difference of water dropping from a height of 21 meters? Yes, I can. How can I do that? By saying I have two energy changes, or it's basically one energy change. From what to what? From gravitational potential energy, to thermal energy, right? What is the equation for the gravitational potential energy? mgh. What about the thermal energy? mc delta T. Can I cancel out the masses? Yes, I can cancel out the masses. To find the delta temperature, it would be gh over c. 9.8 times the height, 21, divided by c, 4,200, which gives you a change of 0.049 degrees Celsius. An ice cube is placed in a beaker and is heated. The ice melts to form water, which evaporates first, then boils. The steam condenses on a cold window in the room. Which process involves the transfer of energy from ice, water, or steam to the surroundings? To the surroundings. Okay? To the surroundings. Meaning that the water kind of will lose energy and this energy is transferred to the surroundings. Which of these processes would transfer energy to the surroundings? The only process that will do that is the condensing. Why? Because the water will kind of cool down, right? It loses energy and this energy is transferred to the surroundings. You might say, well, evaporation, and during evaporation, the water cools. This is if you evaporate the water normally, or if you have a hot cup of water and then it starts to evaporate. if you have a hot cup of water and it starts to evaporate, right? But for this question, there is no hot cup of water. The ice melts to form water, which evaporates first and then boils. This boiling, during this boiling, what happens? The evaporation happens. So in this process, during boiling, you're actually supplying heat to the water, which causes the water to evaporate, which causes the water to evaporate. Okay, a teacher shows his class a cup. Okay, it has a thick, okay, it's a thick plastic with lots of tiny air bubbles in it. He asks the class why the cup is so good at keeping a hot drink warm. Contains air, which is a poor thermal conductor. Is this correct? It is. The air is trapped in tiny bubbles, so very little conduction is possible. Yes, again, the plastic is a poor thermal conductor. It is a poor thermal conductor, so all of them are correct. Two samples of the same material have the same mass but different surface areas. Each sample is heated to the same temperature and then left to cool to room temperature. So both of them have the same mass. They are heated to the same initial temperature and then finally have the same final temperature, which is the room temperature. Each sample is allowed to cool to the same final temperature, which row correctly compares the decrease in the internal energy and the initial rate of cooling for each sample. If we talk about the initial cooling rate of each sample, the larger surface area would have a larger initial cooling rate, right? The larger surface area would have an initial. So we're talking about Y. Y would have an initial cooling rate, a higher initial. Y cools down faster than X initially, right? Initially, I'm talking about initially. Y cools down faster than X, correct. What about the total decrease in internal energy? Total decrease in internal energy. Would you say that Y loses more internal energy than X, or that they both lose the same quantity of energy, or that X loses, for example, more than Y? Which would be correct? To be honest, both of them would lose the same quantity of energy. Why would both of them lose the same quantity of energy? Because both of them have the same mass and they are the same material. They had the same initial temperature and they have the same final temperature, so they will lose the same amount of energy. Even if it takes a longer time, but eventually they will both lose the same amount of energy. In which type of wave is the direction parallel motion? This is the longitudinal waves, which are the seismic P waves or seismic P waves, whatever, right? Waves in a ripple tank are diffracted as they pass through a narrow gap. What can be done to make the spreading greater? We need a greater spreading. Decrease the frequency and keep the speed constant. If I decrease the frequency, what happens to the wavelength? The wavelength increases, right? And if the wavelength increases, then the diffraction increases. So this is correct. Okay, it is correct. Diagram 1 shows the page of a book. Okay, what is the appearance of the image of G seen by the eye? So if you have G and you place it in the mirror, how can you see G? It will be laterally inverted, so left to right, which is D. Not vertically inverted as in C, no, it's laterally inverted as in D. What is the refractive index of diamond? Can I find the refractive index? Yes, N equals sine air over sine medium. But sine air, or the angle of incidence in air, is not 60. What is it? It's 30. What is the angle of incidence in or the angle of refraction in the diamond? It would be 90 minus 78, right? Which is 12. This is the angle of refraction. So basically sine 30 over sine 12, okay, sine 30 over sine 12, which is 2.4. 2.4. Okay. The ray diagrams show the formation of an image. Which row describes the images produced? Diagram 1, is it real? No, it's virtual. Diagram 2, it is real. Yes. White light enters a glass prism and leaves on the other side. Which row correctly describes what happens? The path taken by the light. Is it diagram 1 or 2? Definitely it is 2. Why? Because it disperses, right? And then color 1, would it be red or violet? It would be red, because the red is least diffracted and the violet is the most refracted. Yes. Question 23. Thermal radiation is part of the electromagnetic spectrum. What is the name of this region? Thermal is the infrared radiation. A remote controlled vehicle is traveling on the surface of a planet. The vehicle senses an obstacle ahead, sends a radio message. The control room is 2.4 times 10 to the power of 6 kilometers away. The control room sends back a message. What is the minimum time that elapses between the vehicle sensing the obstacle and receiving the message back? Message back. So this is an echo, isn't it? It is an echo, yes. The speed in the echo. How can I find the speed in the echo? It's 2 distance over time because of the reflection. To find the time, it would be 2 distance over the speed. The distance is 2.4 times 10 to the power of 6. 2.4 times 10 to the power of 6 kilometers. Then you need to multiply by 1,000 and divide by the speed, which is 3 times 10 to the power of 8. If you calculate this, it would give you a total time of 16 seconds. 25. Which statement about the direction of the magnetic field at a point is correct? It is the direction of the force on a north pole placed at that point. Yes, it is. This is the magnetic field. We're not talking about charges. We're not talking about the electric field. Student draws graphs of AC supply and DC supply. Which row shows the correct labels for W, X, and Y? What is W? What is W? It is the axis, right? W is the axis of what? Yes, W should be, exactly. It should be voltage, not time. It shouldn't be time. This should be time. This axis should be time, yes. W would be the voltage. What about the AC supply? It is Y. What about the DC supply? It is X. Moving on to 27, the resistor transfers 100 joules of energy when a charge of 10 coulombs flows through it. What is the potential difference? Potential difference would be the energy over the charge. So 100 divided by 10, which is 10 volts, not 10 watts. 10 watts is wrong. We have wire X and wire Y made of the same metal. Can I find the resistance of wire Y? Yes, the length has increased, the cross-sectional area has decreased, the resistance of X was 2. Can I find the resistance of Y? Yes, to find the resistance of Y, what do? I say that R2 would be equal to R1 times the new length over the old length, which is L2 over L1, times A1 over A2. Basically, we say that 2 times 1.3 over 1 times 0.4 over 0.3. Why do I say that A1 over A2, not A2 over A1 as the length? Because the area is inversely proportional. The area is inversely proportional. So if you multiply 2 times 1.3 times 0.4 over 0.3, this would give you a resistance of 3.466 or 3.5. Oops. Diagram shows 2 resistors used as a potential divider. What the reading on the voltmeter is 1.8 volts. What is the resistance of resistor R? So if the potential difference is 1.8 volts, can I find the potential difference across the 5 kilo ohm resistor? Yes, it would be 3 minus 1.8, right? Because the total voltage is divided. Total EMF is divided. Not equally, it doesn't have to be equally, but it is divided. The total or the summation of both of these potential differences would be equal to 3. Basically, 3 minus 1.8 is 1.8. 1.2 volts. Now you can cross multiply. 5 times 1.8 divided by 1.2. 5 times 1.8 divided by 1.2. So the resistance would increase, right? Giving you a resistance of 7.5 kilo ohms. Two electrical appliances are connected to the mains supply. The cable connected to one appliance includes an earth wire. The cable connected to the second one does not need an earth wire. What is the reason for this difference? One appliance has a metal case. The one with the earth wire has a metal case. Okay, but the other one does not. Again, correct. It is correct. If you have a metal case, you do need an earth wire. If you do not, then you do not need an earth wire. It's as simple as that. The diagram shows an AC generator. The magnet rotates around a fixed coil. The electromotive force is a sine wave. Okay, the magnet is shown in three positions, P, Q, and R. Okay, the magnetic field in the coil is zero at Q. The magnetic field in the coil is zero at Q. Okay, no problem, right? We have no problem with that. Which statement about the induced EMF in the coil is correct? Which statement about the induced EMF in the coil is correct? So this coil, or actually this magnet is now rotating around the coil, right? This magnet is now rotating around the coil. If you think about these positions, it's quite a weird position for the magnet, to be honest. Okay, the rotation of this magnet around the coil, it's quite weird. But if I want to think about it neatly, I'd find that the magnitude, okay, of the EMF at the position Q is actually larger than at P. Why is it larger than at P? Because at Q, because at Q, what's happening is that it's actually moving, it's actually cutting the coil perpendicularly. Okay, or if you want to say no, it's not cutting the coil perpendicularly, you might say it's cutting the coil faster. Okay, whether it's faster or perpendicularly, then the magnitude of the EMF at position Q would be larger than the position P. Okay, it's changing most rapidly. If you say changing most rapidly, then it's faster, meaning that it would give a larger, okay, a larger output. Most rapidly has to do with the speed, right? It has to do with the speed, and therefore it would be producing the largest EMF. Okay, doesn't have to do that much with cutting perpendicularly or parallel, but it would have to do with the speed of the rotation. Okay, the speed of the rotation. A 24-volt power supply and the 100% efficient transformer are used to light a 6-volt 12-watt lamp. What is the current in the power supply? What is the current in the power supply? A lot of you might say, well, 12 divided by 6 is 2, and the answer is 2 amps, which is wrong. Why? Because the 2 amps is not the current in the power supply, it's actually the output current. It is the secondary current. Can I find the input current? Yes, I can find the input current. The output current is now what? It's 12 over 6, so it's 2 amps. This is the output current, or you can say IS. Can I find IP? Yes, VP IP equals VSIS. VP is 24. I need to find IP. VS is now 6 and IS is 2. Right? If you divide by 24, this would give you a current of 0.5 amps. The scattering of particles by thin gold foil provided scientists with the evidence for a nuclear for the nuclear atom. Which particles were scattered by the gold nuclei? Definitely the alpha particles, yes. The nucleus X has 17 protons and 18 neutrons. Which notation is correct? So you have to write 17 at the bottom, and then you have to add 17 and 18, giving you 35, which is D. The dashed line shows the decay curve for a sample. The count rate includes the background radiation. It includes the background radiation. Which curve shows the corrected count rate for the decay? Corrected. If I remove the background radiation, it would be A, would it increase? No, it would actually decrease. It would decrease, as in B, right? It would decrease. So this was the original one, the dashed line. This was the original one, the dashed line, and then the corrected one is the solid line, which is less than the original one. Which type of radioactive source is suitable in measuring and controlling the thickness of paper in a paper manufacturing factory? Can I use alpha? No, I cannot use alpha because alpha wouldn't be able to penetrate the paper. It wouldn't be able to penetrate the paper. Okay, so I should use beta. Long or short half-life? Should I choose short half-life? So no, not short. When I'm talking about short half-life, I'm talking about milliseconds, microseconds. Okay, we don't need these very short half-life beta emitters. We actually need slightly longer. Okay, we need slightly longer beta emitters. 37. What is the half-life of the source? So I'll take the initial count rate, 10,000 divided by 2, which is 5,000. So from 5,000, I'll draw a line, which would be 2 minutes. 38. The Earth orbits the Sun once approximately every 365 days. The average radius, what is the average orbital speed? The speed would be 2 pi r over t, in which the radius, r is the orbital radius and it's in meters. Okay, so 2 pi times 1.5 times 10 to the power of 11 divided by t, or the orbital period, 365 days. But you need to convert it into seconds, right? 365 days times 24 hours times 60 minutes times 60 seconds, right? Which will give you an answer very close to 3 times 10 to the power of 4 meters per second. Okay, 30,000 meters per second. Which statement about the life cycle of the star is correct? The life cycle of a star is correct. This is an easy answer, to be honest. All stars eventually run out of hydrogen as fuel, which is correct. Yes, they all run out of hydrogen. A red giant forms a planetary nebula? No, this is not a super red giant, right? What white dwarf eventually forms a black hole? No, it does not. Most stars expand and form protostars? No, they do not form protostars. They form red giants or red supergiants. A galaxy at a distance of 3 times 10 to the power of 21 kilometers is moving away from the Earth at a speed of 7,000 kilometers. Can I find Hubble's constant? Yes. Hubble's constant would be equal to V over D. Velocity, 7,000 divided by distance, 3.1 to the power of 21. Using my calculator, it would give me an answer 2.2, which is almost 2.3 times 10 to the negative 18. Can I find the speed? Yes, the speed would be equal to Hubble's constant times the distance. Okay, so 2.3 times 10 to the negative 18 times the distance, which is 6.2 times 10 to the power of 21, giving you a speed of 14,000 kilometers per second.